Today we're going to be looking at experimental probability and using the results of experiments to predict what might be happening in the future. So theoretical probability is what we looked at yesterday, and that probability is what you would expect to happen in a perfect world. So if you flipped a coin 10 times, you would expect tails to come up 5 times and heads to come up 5 times. Experimental probability is what actually happens when you flip that coin and record the results in a frequency table. The probabilities are still calculated the same way using the number of favorable outcomes or possible outcomes over the total number of outcomes. So it's still going to be presented in that fraction form. And as more trials are conducted, the experimental probability generally does get closer to the theoretical. So if you flip that coin 100 times versus 10 times, you would get closer every time you flip to that 50-50 proposition. So let's just look at a frequency table here. So a dice is rolled 100 times and the outcomes are recorded. Sometimes you'll see the frequency called the relative frequency. Same thing, relative frequency and frequency. So here you have your frequency table where the outcomes were recorded. So when you rolled the dice 100 times, 1 showed up 16 times, 2 showed up 20 times, 3 showed up 22, and so on. So when you write them as an experimental probability, you're going to put the relative frequency over 100 because 100 was the time, how many times the experiment was conducted. Remember, you always need to reduce down your fractions. So 16 100ths reduces down to 4 25ths, 20 100ths reduces down to 1/5, and so on. So Anna conducted an experiment using the bag of marbles to the left, and she recorded the results in the frequency table. So the first thing I need to do is find out how many times she conducted that experiment. So I'm going to add these together, and she conducted the experiment 55 times. So when I write the experimental probability, 55 will be the denominator. So let's write each event as a fraction. So blue was 15 out of the 55. So it showed up 15 times out of the 55. I can reduce that down, dividing both of them by 5, so I get 3/11ths. Red, the relative frequency for red was 19 out of the 55. That is not reducible. And the relative frequency for the green was 21 out of 55. So here we have the same experiment conducted 55 times. But now they want to know what would happen if they conducted the experiment an additional 110 times. How many times would you expect that green to show up? Well, we can use what we know about proportions to predict probability. So if green showed up 21 out of 55 times, how many times would you expect it to show up out of 165 times? Because there's that 55 plus the additional 110. So we're just going to cross multiply, divide. So 21 is to 55, as 63 is to 165. Here's that same experiment conducted 55 times, but now we want to know how close is the theoretical to the experimental. So here I've got my experimental probability recorded over here. That's just what we did on the last pages. But then I calculated my theoretical probability. So there are 10 marbles in the bag. 4 of them are blue, 2 of them are red, and 4 of them are green. So I'm just going to compare the theoretical with the experimental. So here it is for blue. I've got 3 out of 11. Here's my blue, 3 out of 11. How does that compare to 2 out of 5? So I'm going to use what I know about comparing fractions and just do those cross products. So if I take 5 times 3, I get 15, and 11 times 2, I get 22. So theoretical is higher for blue than the experimental. So let's just keep doing that. So I have 19 55ths. How does that compare to 1/5? So now we're doing the red. So this is 55, and then 19 times 5. Sorry, it's 95. So in this case, Experimental was higher. So then let's do it for this last one, 21/55 and 2/5. So when I cross multiply, this is 110. And then 21 times 5 is 105. So in this case, the theoretical was larger.